In Module 4, Lesson 30, we're going to look at one-step problems in the real world. So we're going to start off by drawing an example and a brief description of each word, and these, of course, are angle terms. So we can see the three angles. An acute angle is an angle measuring less than 90 degrees. Obtuse is an angle measuring more than 90 degrees and less than 180 degrees. 180 degrees is a straight line, so we cannot extend past that. And a right angle is an angle that measures exactly 90 degrees. The right angle, the 90-degree angle, is kind of our test for everything. And one quick way, without using a protractor, is to take a sheet of paper and fit it inside the angle. If it fits exactly inside, that would be a right angle. If one of the rays is extending past, that would be obtuse. And if you fit the piece of paper inside and the other ray is covered up, that would be acute. And our final two types of angles, we have our straight angle, which is a straight line, an angle that measures exactly 180 degrees. It does not have to have some point measured in the middle. If you see a straight line, it's 180 degrees, and it is a straight angle. And then reflex is this measurement, the outer part, and this outer angle would be between 180 and 360 degrees. You'll notice that the angle, a reflex angle, is actually the opposite of an acute angle. So it's the part that is around the acute. So we use that information now in order to solve these problems. If angle ABC measures 90 degrees, and we know that because we have a little box inside the right angle, and right angles are normally marked with that box. And so we find that one angle measures 57 degrees, and the other angle we're looking to find out. The two angles are related by the fact that they equal 90 degrees altogether. They have a sum. The two angles have a sum of 90 degrees. So our equation then would be 57 plus x equals 90. And we solve. And at this point, after all of the problems we've been working prior to this, we should know this is a very basic equation. We'll subtract 57 on both sides and find that x equals 33. Example 2, Michelle is designing a parking lot, and she has determined that one of the angles should be 115 degrees. The measure of x and y are what we're looking for. So angle x is related to the 115 degree angle in the fact that they create a straight line. Which is also what we call a straight line. And just like we talked about fitting a piece of paper into a right angle, you can use a piece of paper to check the straight line as well by laying it flat on the straight line and seeing if it is straight. The equation then that would show that is x plus 115 equals 180, and we'd solve that, again, very simply, by subtracting 115 from each side And then we'll find that x equals 65. And this is a very interesting relationship because the second part of this problem asks us how angle y is related to the 115-degree angle. And if we lay a sheet of paper down along those two, we also find that they also create a straight angle. In which case we know that the measurement of y is also 65 degrees. So x and y are what we call congruent. They have exactly the same measurement. And their relationship, which we'll talk about later as well, is that they are what we call vertical angles. They are created, they are opposite when you have two intersecting lines. And they are always congruent. They always have the same measurement. In example 3, a beam of light is reflected off of a mirror. This is the diagram of the reflected beam. We need to determine the missing angle measure. Now the angles in this question are related in the fact that they create a straight line. Again, just like we had before. Which remember is 180 degrees. So the equation that we would write is 55 plus x plus 55 is equal to 180. And then to solve that equation, we'll need to add the 55s together first. And this is, remember, it's addition, which is commutative. So we can add 55 and 55 first, which is 110 plus x equals 180. And then to solve it, we'll subtract 110 from both sides. And we find that x equals 70. When we look back, if we add 55 and 55, which is 110, plus 70 is 180, we find that it does match. So we'll do some similar problems in our exercises. Number 1, angle ABC, this is the symbol for angle, measures 90 degrees. It has been split into two angles, angle ABD and angle DBC. Please notice we have to use 3 letters to name these angles because one letter, angle B, doesn't tell us anything. The measure of the two angles is in a ratio of 2 to 1. So we need to find the measure of each angle. That means then that ABD is twice as big as DBC. So when we set that up, we would know that 2A represents ABD because it's twice as big as DBC, and A is DBC. When we add them together, we get 90 degrees. So 2A plus A is 3A equals 90. We'll divide by 3 on both sides and find that A equals 30, which means then that our second angle, this bigger angle, is 60 degrees, and the smaller angle is 30. In number 2, they ask us to solve for x, and hopefully you can see that these 3 angles together are creating a straight line. So to solve for x, we'll write an equation that is 64 plus x plus 37 equals 180. And then to solve, we'll add 64 and 37 together, which will be 101 plus x equals 180. So then we know that x is equal to 79. We subtract 101 from both sides, and x is 79. In number 3, Candace is building a rectangular piece of fence according to the plans her boss gave her. One of the angles is not labeled. She'll need to write an equation and use it to determine the measure of the unknown angle. So she has this 49 and 8 and x degrees. This angle below is labeled as a right angle. So it makes me question, is this one also a right angle? Since it's not marked, I'm going to go back into the problem and read it again. Candace is building a rectangular piece of fence. What do we know about rectangles then? Well, we know that a rectangle is made up of 4 right angles. So that would mean that this angle is actually a right angle, or 90 degrees. Now that we know that piece of information, we can go and write our equation and solve our equation quite simply. 49 plus x is equal to 90. And to solve, we'll subtract 49 from both sides. And we find then that x is equal to 41 degrees. In number 4, Rashid hit a hockey puck against the wall at a 38-degree angle. The puck hit the wall and traveled in a new direction. We need to determine the missing angle in the diagram. Please notice 38 degrees on this side, 38 degrees on this side, and some unknown angle in the middle, but all 3 together make a straight line. So we're going to write the equation 38 plus 38 plus x equals 180. Then we'll combine 38 and 38, which will give us 76 plus x equals 180, and we'll subtract 76 from both sides. And find that x equals 104. And in our final problem, we don't have a drawing. Jackson is creating a mosaic design on a rectangular table. I notice rectangular, so I know I have 90 degrees. He has added 2 pieces to one of the corners. The first piece has an angle measuring 38 degrees that is placed in the corner. And the second piece has an angle measuring 27 degrees that is also placed in the corner. We'll need to draw a diagram to model the situation, and then write an equation and use it to determine the measure of the unknown angle in a third piece that could be added to the corner of the table. So first of all, I want to draw the corner. This is the corner of the table. It's 90 degrees. And he's added 2 pieces to one of the corners. Here's one, and here's a second piece. I know that the first piece created an angle that's 38 degrees. And then I know that the second piece created an angle that is 27 degrees. And we're looking to find the third angle. So we're going to write an equation, 38 plus 27 plus x, which is our unknown angle, will equal 90 degrees. because the corner in a rectangle is 90 degrees. We'll combine 38 and 27, which is 65, plus x equals 90. And then finally subtract 65 from both sides. And find that x equals 25 degrees.